We are currently in Tech Math 2, and this video is going to cover section 9.7 only. And we have two new rules in 9.7. We're going to solve equations that have logarithmic things in them. And so our rule says if I have something that says log base b of x is equal to log base b of y, then that clearly implies that x has to be y. So with a little bit of help, this will just be one equation, one unknown, and our calculator ought to be able to solve them. And I would imagine that's going to be the case. I guess we have something else, and it says y is equal to log base b of x. That's the same thing as saying x is equal to b to the y. So these are equivalent ways of writing the same equation. So depending on which one is useful to us will depend on which one we're using. All right, so now I'm going to look at number 1. And I have a log of 3x minus 4 is equal to the log of x plus 6. All right, so what do you think we should do with something like that? Well, we could start putting in answers, I suppose. But the log of this is equal to the log of that, so this has to equal that. So 3x minus 4 has to equal x plus 6. So 2x has to equal 10, and x has to equal 5. And why am I so messy in my notation? I don't know. Beats the heck out of me. Okay, that seemed... we'll check our work. 15 minus 4 is 11. 5 plus 6 is 11. The log of 11, is the log of 11 equal to the log of 11? Log 11 equal log 11. Oh yeah, it is. Okay, good. Of course, that looks sort of like log of pi equal log of 11, but other than that, we're okay. All right, so that was number 1. And now we're all warmed up, and I got my pen pointing the right way. I think the problem is, there we go. My touch was on, so that meant that my pen was dragging. All right, number 3. Natural log of x minus 4 equals natural log 2x plus 5. Well, if that's the case, then x minus 4 had better equal 2x plus 5. Minus x is equal to 9. X is equal to minus 9. No, it's not. Um, 9 minus 4 is minus 13. 8 minus 18 plus 5 is equal to minus 13. But I can't take the log of a negative number. So that means that this has no solution. No solution. That'll be good, because when Ben tries to work this on the quiz, he'll get it wrong, because he's going to tell me the answer is minus 9. Because I can't have the log of minus 13 being the log of minus 13, because I can't take the log of a minus number. So this can't be, cannot be. Would there be any other solution to that? Probably not. What's the back of the book say? Anybody know? Section 9.7. 9.7, number 3. No solution. Wow. The grad student got it right. All right, well, that was all right. Number 6. So now we know the author can hose us over and give us the wrong solution. Gives us something with no solution. Log x plus 1 log 5 plus log x minus 3. Well, we are not in the form log of something is equal to log of something, so we need to get to that form. And so if I add logs, it's the same as multiplying. So this is log of 3 times x plus 1. And that's going to be equal to the log of 5 times x minus 3. And then that now I'm inside one log, so I got 3, we'll change colors, 3x plus 3 is going to equal to 5x minus 15. All right, well, okay, so we'll bring the minus 15 on the other side. 18 is equal to 2x. X is equal to 9. Okay, x is equal to 9. All right, so 9 plus 1 is 10. I have 30 over here. 9 minus 3 is 6. 6 times 5, I have 30 over there. So log of 30 is equal to log of 30. Check. Okay, that worked out all right. Number 10. The log 3x plus the log 2x is equal to the log of 150. All right, well, again, I'm going to have to combine them, so adding logs is the same as multiplying, so that's the log of 6x squared is equal to the log of 150. So 6x squared is equal to 150. And does 6 go into 150? Yes, it does. So x squared is going to be, let's see, 6 goes into there twice. 6 goes into 35 times. X is equal to plus or minus 5. And then we all come back and say, if it were minus 5, I would be taking negative logs. So the minus guy isn't going to work. Get rid of him. And if it's the 5 guy, 5 squared times 6 is 150, so that looks like it'll check. So I only have one answer, and the one answer is x is equal to 5. Now what we're going to do before we go on, we're going to put that equation in our calculator using our numeric solver. And so we're going to say the log of 3 times x plus the log of 2 times x, close parentheses, delete the guys that I don't want, equals the log. So it's in my calculator. I'm hitting the solve button and I'm solving for x. And I know the answer is 6 because I already got the answer is 6. It's telling me the answer is 5. Oh, right. The answer is 5, right? Yeah, 5.0. Mine doesn't say 5.0, it just says 5. So the calculator is going to do that problem for us, so isn't that special? So I don't expect any log problems to be missed on the next test. Number 12. Log of 2x plus 1 minus log x minus 4 log 3. Alright, so I'll rewrite it log 2x plus 1 divided by x minus 4 is equal to log 3. Isn't that special? Alright, so I think I've already solved this problem before, haven't I? 3x plus 1 over x minus 4 equals 3. 3x plus 1 is equal to 3x minus 12. 1 is equal to minus 12. That doesn't look good. Oh. So if I change the problem back to the original problem, maybe I will do better. What do you think? Yeah, all right. So now I can say x is equal to 13. X is equal to 13. All right. And so that teaches me that if I'm going to solve the problem right, I can't change the problem and then roll the stream, right? So log of 13. 13 times 2 is 26. Plus 1 is 27. Let's see. 13. 13, 2, 26. 27 on top. 13 minus 4 is 9. 9 goes into 27 3 times. Check. Okay. So that works just fine. And we'll go put it back in our calculator, see if our calculator likes it. Second function, numerical solve. Log of 2x plus 1 minus log of x minus 4 equals log 3. Bum, 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 bum. 13. Wow. Smart calculator. All right. Yeah, we're not gonna. Yeah. I guess we'll do 19 next. 19. The log of x minus plus 1. X plus 1 is equal to 1. Okay, so x has to be 9. So we know x has to be 9 because 9 plus 1 is 10 and the log of 10 is 1. So we know the answer is 9. Now how are we going to get that answer? Alright, well, we're going to raise both of these. We're going to use them as powers of 10. So 10 to the log x plus 1 is going to be x plus 1 is equal to 10 to the first, and then we're going to have x is equal to 9. So I can do it using math. Oh wow, using math. What a novel idea that is. That is so novel. Let me check this out again. So we got a problem, and it's log of x plus 1 equals 1. And we solve it, and wow, it tells me the answer is 9. So 19 is 9. So I guess we should find something harder than that, right? How about 24? Number 24. Log 2x minus 3. Well, I guess we have to go back and do 22 first, don't we? All right, we'll go back and do 22 then. Number 22. Then we'll do 24 after 22. The natural log of x minus 1 is equal to 2. Way to go. Use the big eraser all the time. X minus 1. Okay, so I'm going to raise both of these to powers of as powers of e. So e to the natural log of something gives me the something. X minus 1 is equal to e squared. So x is going to equal e squared plus 1. Way to go. E squared plus 1. Now, is there any good reason to change that to 3.71828? Not particularly. There's nothing wrong with that solution. And if I put the solution back there, I have natural log of e squared, which in fact is 2. So my solution checks. All right. Back to number 24. Log 2x minus 3 minus 3 log 2. 3 log 2 equals 1. All right, so we have to put that into one thing. All right, so that's log of 2x minus 3 divided by 8. Because we put the 3 as an exponent of the 2, and 2 to the third is 8. And that's going to be 1. We're going to raise, both sides are going to be exponents of 10. And that gets rid of the log guy, and we get 2x minus 3 over 8 is 10. 2x minus 3 is 80. 2x is 83. X is 83 over 2. That seems weird, doesn't it?
Would you get that data again?
83 over 3. 83 over 2. 8?
Yeah.
Oh. 3 log 2 is log 2 to the cubed, which is log 8. That's how I got it. So when I'm multiplying logs, it's the same as taking powers. When I'm adding logs, it's the same as multiplying. 83 over 2, that seems weird. All right, back to my calculator. Second function quit. All right, second function, turn on the solver again. All right, log 2x, 2 times x. 2 times x minus 3 minus log minus 3 minus 3 times log 2 equals 1. And thinking about it, thinking about it, thinking about it, still thinking about it. I don't know if it's thinking about it or not. No, it's still thinking about it.
41.49.
That's what this is. 41.5 is what it should be, right? Mine's still thinking about it. Thinking. Well, 41.49 would be 41.5, so that'd be, hit the solve again from there, see if it gets closer. See, I started from x is equal to 9, which is too far away.
I put x equal to 2.
We put x is equal to 2. Yeah. Yeah, we're still thinking about it over here.
So when you put in for x, you can basically just put whatever number.
Yeah, you put in whatever guess. That's why it says do it again. So if you put in a bad guess, you might get a bad number out, and that's why it says do it again. Yeah, I'm still in a do loop here. Anyway, so there's nothing wrong with 41.49 because that rounds up to 41.5, which is our answer. Okay. In the meantime, my calculator is stuck in a continuous do loop here, trying to solve something. We'll do, well, I don't see anything hard here. 27? That's not very hard, but we'll do 27 next. Natural log 2 plus 1. 2x plus 1. Natural log 3 is equal to 2. So I'm going to write that. Natural log of 6x plus 3, skipping some steps, is equal to 2. And then I'll raise those as powers of e and get 6x plus 3 is equal to 2, e squared, equal to e squared. So 6x is equal to e squared minus 3. X is e squared minus 3 divided by 6. E squared minus 3 divided by 6. All right. E, yeah, I'm still solving. All right, so I quit out of there. E squared minus 3 divided by 6. And I get a 0.7315. 0.7315. All right, we'll go back to my glorious calculator, see if I can get in another do loop here. Natural log 2 times x plus 1 plus natural log of 3 equals 2. And we're gonna guess 1. All right. 0.7315. Oh yes. 0.7315. And my work checks on my calculator. Boom. Excellent. Okay. We'll move down to 35.
What was that last one? 30 what?
That was 27.
No, on the board you got 30 something, you can't see it.
Oh, that's a 35. Yeah, that's what I'm doing, 35. Yeah, that's a 35. Are you trying to tell me you can't read my writing? After being in the program for 5 years, you still can't read my writing? Oh well, can't have everything. Natural law.
Might be 5 years.
Oh, it hasn't been 5 years yet?
Might
Okay.
be 5 years.
It might be, yeah, it could be, yeah, I can tell. Natural log. You just want to hang out till you can be in the new building. That's what you want to do. 2x minus e. Minus 2 is equal to natural log 2. Looks like I should just put this in my calculator and not worry about it, right? Well, clearly I got to get the natural log 2 on the other side. I got to get the minus 2 on the other side. So I'm going to have the log, natural log. These guys are multiplied. So I'm going to have 2x squared minus ex divided by 2, because that's going to be minus the natural log of 2, so that's going to be dividing, and that's going to be equal to 2, and I'm going to raise these as powers of e, and I'm going to have 2x squared minus ex over 2 is equal to e squared. All right, so I've got x squared minus e over 2x minus e squared is 0. So I have a quadratic guy, and I should just put it in my calculator to solve, right? So I'm going to go to second function, polynomial solver, second degree. Okay, so my x is a 1. My b is a minus e divided by 2. And my c is a minus e squared. And I hit the solve button, and it says I have x1 minus 2.122, which will be more than enough significant digits, and then I've got an x2, and my x2 is 3.48. 3.4, we'll go with just 3.484.8. Okay, now the negative guy is very suspicious. If I put a negative number here, then I don't have an answer. So the negative answer is obviously a wrong answer. Boom, boom, get rid of it. Now is 3.48 a correct answer? So we'll use our numerical solver, and I have natural log x plus natural log 2 times x minus e, close parentheses, equals minus 2.
That was 3.
What?
That was 3.
Where's 3e? Oh, bummer, I solved the wrong problem?
Yeah.
Now you tell me. Alright, so I'll put in 3e. Insert 3, insert times e 3e. Alright, that's what happens when Ben isn't here. He can't tell me what the right problem is. Natural log So we'll get the right answer first, and then we'll go and figure out how to get it second. All right. Alright, so the calculator is doing its thing, and while the calculator is doing its thing, we'll come back here with my red ink and say, gee, there's a 3 here, and there's a 3 there, and there's a 3 down here, and there's a 3 down there, which means that neither of these guys are right. Error. Uh-oh. Calculator thought I had an error. Alright, so there may not be an answer for this guy. Second function, polynomial solver. Okay, so I want a 1, and I want a minus 3 divided by 2 times e. And this guy here, I still want minus e squared, right? Alright. So now I've got 2 new answers, seeing that I'm solving a different problem. X is equal to minus 1.36, and x is equal to 5.44. 5.44. Well, back to the original argument, it can't be that one. Okay, so it has to be 5. Did I get 5.44? Did I ever? No, I got an error, right? I got an error when I was trying to solve it, so I don't know what the right answer is. This is 35, though. I can look in the back of the book. Section 22, I don't think so. Section 6. Section 11. 9. 9.7, number 35. Ooh! 5.437. Is that what I said it was? Yeah. Except I rounded up to 5.44. Okay. Alright, well that was good. Finally got that one done. One more. Yeah. Got a problem? No problem? Alright. Well, one more and then we'll go home. Well, we won't go home, but whatever we're going to do next. 36. Natural log x times 2x minus e. Let's see if I can write the problem down right. Divided by 3 is equal to 2. Alright, looks good. We'll raise it as powers of e. And we're going to have 2x squared minus e over 3x minus e squared is equal to 0. Okay, that looks good. And then we're going to go and solve the quadratic formula. Okay, so x is equal to minus e over 3, which is minus. So that'd be plus e over 3 plus or minus square root of e over 3 squared minus 4 times a times c divided by 2 times a. All right. Somehow I think I'd rather just put it in my calculator, write down the right answer. E over 3 plus or minus everything divided by 4. Okay, so I got e squared over 9, square root of e squared over 9 plus 8 e squared. Okay. All right. E over 3 plus or minus e square root of e 2/3 e square root of 2. that's just so wrong.
You got an answer of 4.07.
Let's see, 4.07. So that's what we're looking for. All right, e squared. So I can bring out the e. So it's going to be 8 plus 1/9 over 4. All right, so now I got e over 12 plus or minus e divided by 4. Okay, what's 9 times 8? 9 times 8 is 72. Yeah, so the square root of 73 over 3. The negative guy is not going to work, so only the positive guy can work. So e
72, not 73.
72 plus 1.
Oh,
Yeah. So I've got e divided by 12 plus e divided by 4 times the square root of 73 divided by 3. Well, isn't that just special? 2.16. Okay, so according to Nate, I am wrong.
I could be wrong too.
Oh, bummer. So there's a possibility you're wrong too? Okay, so we'll put it in my calculator, see what my calculator says. And because this is even, we don't have an option of looking in the back of the book. 2x minus e minus 2 minus 2 equals natural log 3. And we're going to guess, what was your guess?
4.0.
We're going to guess 4. Okay, so we're going to guess 4. Well, we're going to guess my guess, 2. There we go. Going to guess 2, see if we get 4. Oh, 4.077. 8 was correct. Oh, well, luckily we've run out of time, so I won't be able to figure out where my error is. Oh well, can't have everything.